Hi friends, it's your favorite math teacher again, Mrs. Hofline. Today we are going to model the relationship between multiplication and division using both tape diagrams and number bonds. Let's start with a number bond. I'm going to draw my total 24. 24, and I'm going to draw one part coming out of it, one part with 4. When I look at this, I see blank times 4 equals 24. A certain number of groups, which is my blank, times 4 in each group equals 24. I can skip count to find the unknown factor. Each time I write my 4 down on my paper, I'm going to go up to my number bond and draw a new part. So let's skip count. 4, which is right here. 8, so I'm going to draw another 4. 12, let's draw another 4. 16, let's draw another 4, another part. 20, let's draw another 4 for that. And 24, so let's draw another 4. 4. When I look at my skip counting, I counted 1, 2, 3, 4, 5, 6 4s. And when I look at my number bond, I have 1, 2, 3, 4, 5, 6 parts coming out of my 24. So I know that 6 groups of 4, or 6 times 4 equals 24. So I can easily use skip counting to solve that number bond. However, when I look at this, I can now look at this and also see a division problem. My whole is 24. So I can take my 24 and I can divide that. Divided by 4 equals 6. I have seen many of you guys writing both the multiplication and the division sentence with your tape diagrams. It works here just the same for number bonds. Let's draw a second number bond. Next to it, let's draw a total of 24 again. But this time, I'm going to draw 4 parts. And in those 4 parts, I'm going to have question marks. Just like that. So take a minute and draw that on your paper. How can we use the problem we just did to help us solve this problem? I see my total is 24, and this time I have 4 groups. So I can use the division problem 24 divided by 4 equals 6, because I just did it right there. This time my unknown is the size of each group, which is why I have question marks for size of each group. These are the same exact equations, but our quotients are representing different unknowns based on our number bonds. This 6 is how many are in each group. This 6 represents the number of groups I have. Let's take a look at problem 2 on the back. Problem 2 reads, a classroom has tables that seat a total of 20 students. 4 students are seated at each table. How many tables are there? So let's start annotating this question. A classroom has tables that seat a total of 20 students. 20. 4 students are seated at each table. How many tables are there? So in this case, I'm finding the number of tables, which is the size or the number of groups I have. So when I draw my tape diagram, I don't know how many groups I'm going to have. I do know that there's 4 students seated at each table. So when I draw my tape diagram, I know to draw it with a dotted line to represent the fact that I don't know how many groups to break my tape diagram up into. I can label this for students, and I know that my whole tape diagram represents 20 students altogether, because that's what it says in my word problem. They're asking me to find how many tables I need, and the tables are going to be the number of groups. Without solving, let's write a multiplication and division equation with an unknown factor to represent the drawing. So I know that my division problem would be 20 as my total divided by 4 equals what? What does it equal? Big question mark. And my multiplication would be blank, because I don't know how many groups. So blank groups with 4 in each group equals 20 altogether. So how many groups? The unknown, or the question mark, that I have in both equations represents the number of groups. To solve the addition, I can add a unit of 4 to the tape diagram until I get to 20, which is just skip counting by 4. Skip counting is also a way to solve the multiplication too. The strategies are the same for both equations because you can use one to solve the other. So let's skip count by 4 until we get to 20. 4, 8, 12, 16, 20. 1, 2, 3, 4, 5. I skip counted by 4 5 times, so I know I'm going to need 5 groups. So there's 2 4s, 3 4s, 4 4s, and 5 4s. There's my 5 groups. And I can come over to my equations now and erase. I'm going to try to erase. But erase my question marks. And I know now that 20 divided by 4 is 5. And 5 groups of 4 equals 20. We can represent both number bonds and tape diagrams with both multiplication and division equations. I have seen a number of you guys been doing this the last couple of times we've been solving with tape diagrams. Just continue to represent both the tape diagrams and number bonds with both multiplication and division. On the problem set now, work with your group to write both of these equations for the model you choose to draw, whether it's a tape diagram or a number bond. Good luck.